I'm Kellian, co-founder at SevenLabs. Today I'm going to be talking about Carbon, the data pipeline for Solana. So Carbon is a Rust framework to build indexes on Solana. Just for more context, we've been a dev shop for about 2 years on Solana, and about a year ago, we realized that a lot of teams were basically just rewriting the same pieces of code. So for sourcing data, be it historical or real-time data, for decoding it from their IDL, and also for processing it, so like storing it or triggering workflows. So that's when we started actually building Carbon, and the goal was to have a single pipeline that is modular and that you can just plug things into. So just so you get a bit of an understanding of how you actually compose a Carbon pipeline, you can plug in any data source, and here we actually support most of the ways in the ecosystem to get data. You can then attach decoders for instructions and accounts. This will directly use your IDL. And then you can add processors like for Postgres storage, or could be really anything. And then you just run the pipeline end to end. So as you can see in the code, you have a simple builder pattern. You can choose your source, then add the instruction and account pipes, and you have your indexer ready to run. So let's get into each of the components a bit more deeply. The first one is data sources, as I mentioned. So it's a component that sends account and transactions into your pipeline. And so it's modular, so it's a trait. That means if you have a custom endpoint from an infra provider, or if you have a local dump of data, you're able to simply ingest it into your pipeline by implementing that trait. But of course, for most people, they don't want to do that. They want to just use something that's already implemented, because there are standard ways to actually get data to index. For real-time data, that would be gRPC, and for historical data, there's been a lot of teams pushing it this year. So as the ecosystem grows, we actually maintain and publish a lot of different crates for data sources. So I think this year there's been a lot of teams pushing historical data. On the OSS side, there's been Triton and Anza that have been building Old Faithful, the archive, and Jetstreamer. So we've integrated that. That means you can pretty much just for free stream historical transactions to your Carbon pipeline. And that's at very high speeds. So that's a good one. And then on the vendor side of things, you have Helios that has released get transactions for address as a new RPC endpoint. And so these are all methods that you can directly plug into Carbon, and you'll get the data inside your pipeline. So that's an example of how you would do it. This would be for the Jetstreamer data source. So as you can see, you just choose your slot range, you choose your filters, and you're able to add it to your pipeline. Would work the same way with other data sources. You'd simply import another crate. So then at that point, you have all of your raw data flowing inside your pipeline. And so you need then to make sense of it, because that is the main point of Carbon, actually. It's getting all of your updates and then doing what you want with them. So here, again, you have two traits inside the framework, but you don't really have to implement them. You could implement them if you want a custom deserialization logic, pretty much. What you can do, and what most people should do, is actually use the CLI. So the CLI works with any IDL. So we support Anchor and Column IDLs, and it will basically generate the whole decoder implementation from that IDL. That means you can then just import the code that's been generated and add it as an instruction or account pipe, and you'll have all of your decoded account or instruction updates for your program directly flowing to your pipeline. Once you've done that, you just need to do whatever you want to do with that data, and that is the part that actually you will spend most times writing when you're using Carbon. So this is also a trait that you can implement, and you can do whatever you want inside of it. The good thing is basically you get all of your decoded updates, and you can use it. So here you have a logger implementation as an example. So what this would do is actually load the decoded updates, and it would also log some transaction metadata. So you have access to the whole instruction or account update, all of the metadata that you need, and most importantly, your decoded type. So something that's cool actually about the CLI is if you generate your decoder through the CLI from your IDL, you have a Postgres feature that is already implemented inside the generated crate. And so if you enable it, you'll be able to directly use our Postgres account or instruction processor, and you'll be able basically in a few lines of code to have a full index of all of your accounts and instructions in like a few lines of code inside Postgres. So here, you just use the migrations inside of the generated crate to generate your tables, and then write this pipeline, and you'll have pretty much everything running. You just need like a gRPC connection to whatever infra provider. So this wraps it up for how you would actually use Carbon, and I recommend that you guys also use the scaffold command of the CLI to try to generate a project and like play with it. But it's really simple to use, and after about a year experimenting with the API of the library, we're going to go to V1. So we're going to have a stable API across all core crates. We're going to follow a semantic versioning finally. We've had a performance update with like more than 5x in raw pipeline throughput, which is huge for historical backfilling because you're able to basically have a JStreamer data source and have between like around 100K that 100K TPS that flows through your pipeline and that you then just decode and index. So it's actually very quick to do historical backfills with V1 now. We've also reworked metrics. We already had a metric system, and it was basically fully extensible, which means you can record any metric that you want with Prometheus, and you can also just log them. But we've made it like way faster, so this is going to be released. And then we are finally going to release a documentation site with guides, examples, best practices, and like a full reference of the framework. So this will help everyone get into it. And this V1 will be the foundation for everything that comes next. So we have more processors for ClickHouse Kafka that are going to be generated off of the CLI command. So it's always gated behind features, meaning most people are just going to want to have their custom logic, so you can have it. We're going to build speed optimized decoders for like the most important programs, so things like SPL token. I mean, probably most SPL programs actually, Solana program library programs. We're also going to build version decoding afterwards, which means you can, based on the version of your IDL, decode things differently based on different slot ranges. And we also have in plans to build language agnostic gRPC streams for teams that want to be indexing in other languages than Rust, because right now you can only index with Rust. So now is a great time if you want to raise issues or if you have any PR that you want to open on the repo, because we're actually currently in the final push to release V1. We've reached more than 500 stars on GitHub recently, so wanted to thank all of our contributors, and thanks for listening.